Let's now try and learn about techniques of programming which are used commonly to solve problems. We'll start with dynamic programming. This is a very powerful technique to solve a particular class of problems. It demands a very elegant formulation of the approach and simple thinking, and the coding part is very easy. The idea is very simple. If you have solved a problem with the given input and then save the result for future reference so as to provide solving the same problem again. If the given problem can be broken up into subproblems, and these smaller subproblems are in turn divided into still smaller ones, and in this process, if you observe some overlapping subproblems, then it's a big hint of dynamic programming. There are two ways of doing this. Number one, top up. Start solving the given problem by breaking it down. If you see that the problem has been solved already and then just returns the saved answer, if it has been solved, solve it and save the answer. This is usually easy to think of and very intuitive. This is referred to as memorization. Bottom up. Here, a problem is analyzed and see the order in which the subproblems are solved and start solving from the trivial subproblem up towards the given problem. In this process, it's guaranteed that the subproblems are solved before solving the problem. This is referred to as dynamic programming. Let's now look at the greedy algorithm. A greedy algorithm always makes the choice that seems to be the best at the moment. How do you decide which choice is optimal? Assume you have an objective function that needs to be optimized, either maximized or minimized at a given point. A greedy algorithm makes greedy choices at each step to ensure that the objective function is optimized. The greedy algorithm has only one shot to compute the optimal solution so that it never gets back and reverses the decision. Let's now look at some advantages and disadvantages of the greedy algorithm. Number one, it's quite easy to come up with a greedy algorithm, or even multiple greedy algorithms for a problem. Number two, analyzing the runtime for greedy algorithms will generally be much easier than for other techniques like divide and conquer. For the divide and conquer technique, it's not clear whether the technique is fast or slow. This is because at each level of recursion, the size of the algorithm gets smaller and the number of subproblems increases. Number three, the difficult part is that for greedy algorithms, you have to work much harder to understand correctness issues. Even with the correct algorithm, it is hard to prove why it's correct. Proving that a greedy algorithm is correct is more of an art than a science. It involves a lot of creativity. Let's now look at linear programming. Linear programming is the process of taking various linear inequalities relating to same situations and finding the best value obtainable under these conditions. In real life, linear programming is part of a very important area of mathematics called optimization techniques. This field used everyday data in the organization and allocation of resources. These real-life systems can have dozens of hundreds of variables or more. In algebra, though, you'll only work with the simple and graphable two-variable linear case. The general process for solving linear programming exercises is to graph the inequalities to form a walled-off area on the xy plane. Then you figure out the coordinates of the corners of this feasible region and test these corners in the formula for which you're trying to find the highest or lowest value. See the video below to know about linear programming.
Welcome to the first video in this linear programming series. In this video, we will graphically solve a basic maximization linear programming problem using the extreme or corner point approach. What we have here is a linear programming or LP model. The x and y in this model are referred to as decision variables. They tell us what quantity to buy, produce, sell, or transport, and so on. The 2x plus 5y here is referred to as the objective function, which we want to maximize. In linear programming, we either maximize or minimize the objective. The next two lines are called constraints. They are restrictions that shape how you attain the objective. Let's call them C1 and C2 for reference purposes. Since we're dealing with real-life objects, we do not expect them to have negative values. So the last line here tells us that both x and y have to be greater or equal to 0. We call them the non-negativity constraints. To solve the model graphically, we begin by finding points that satisfy the constraint lines. For the first constraint, when x equals 0, y equals 8. And when y equals 0, x equals 16. For the second constraint, when x equals 0, y equals 15. And when y equals 0, x equals 9. Now, when drawing the graph, we usually just stay in the first quadrant here, where both x and y are positive because of the non-negativity constraints. So for the first constraint, we have the points 0, 8 and 16, 0. We join those 2 points for the constraint line. We do the same for constraint 2, 0, 15 and 9, 0, and then draw the constraint line. Since these constraints are less than or equal to constraints, they will be satisfied in the region below the lines towards the origin. Therefore, the region satisfying both constraints simultaneously is this one here. It is called the feasible region. That is, any point in this region is a feasible solution. In particular, the optimal or best solution will occur at an extreme point or corner point of the feasible region. These are the corner points for the feasible region. Let's label them 1 to 4. The optimal solution to this linear programming problem will occur in at least one of them. To decide which one is optimal, we will find the coordinates of the point, plug them into the objective function, and then choose the best. At corner point 1, the coordinates are clearly 0, 0. At point 2, 0, 8. At point 4, 9, 0. Now, those are easy to see. For corner point 3, we can see that the coordinates are 6 and 5 by eyeballing, that is, looking at it very closely. But eyeballing is not usually the best way to go when finding the intersection of 2 lines, especially when manually drawing the graph. So let's see a way to solve the 2 equations simultaneously to determine the actual coordinates. Here are the lines for the 2 constraints. Now suppose I choose to eliminate x. Note that the coefficient of x here in C2 is 5. Then I can simply multiply the first equation by 5 to give 5x plus 10y equals 80. And then we can subtract C2 from the new equation. So 5x cancels 5x, 10y minus 3y is 7y, and 80 minus 45 gives 35. And on dividing both sides by 7, we have y equals 5. To now find x, we substitute y equals 5 into any of these 3 equations. Suppose we choose C1. Then we have x plus 2 times 5 equals 16. That is, x plus 10 equals 16, x equals 16 minus 10, and x equals 6. So the xy coordinates for extreme point 3 are indeed 6 and 5. Next, we determine the optimal solution point by finding the corner point that gives the best value of the objective function. The objective function was to maximize 2x plus 5y. As you can see here, the objective function, or its value, is sometimes represented with z. So now, the xy coordinates at point 1 are 0, 0, And substituting that in the objective function gives 2 times 0 plus 5 times 0, which equals 0. And at point 2, we have 0, 8. So the objective function value is 2 times 0 plus 5 times 8, which equals 40. The coordinates at point 3 are 6 and 5. So z equals 2 times 6 plus 5 times 5, which equals 37. And finally, at point 4 with 9, 0, z equals 2 times 9 plus 5 times 0, which gives 18. So here we have it. Point 2 provides the highest value of the objective function. So the optimal solution occurs at point 2, and it is x equals 0 and y equals 8. And the corresponding objective function value is 40. And that concludes the solution to this LP problem.
There are errors which we encounter while programming. Let's learn about some of these errors one by one. Number 1. Runtime error. When there are no syntax errors, but the program can't complete execution, which include divide by 0 or invalid input data. Number 2. Syntax errors. These are errors in grammar of the language. Number 3. Logical errors. The program completes execution but delivers incorrect results and uncommon usage of parentheses. There are different languages which come into the picture in order to develop softwares. Programmers use different languages depending on the purpose of the program. For example, COBOL is used for business applications. Some other languages are these which are high level. For example, Java. Java is a programming language that was developed by Sun Microsystems in 1995. It was originally designed for programming small computing devices, but now in industry computers. It is probably one of the most used languages in electronic devices. It can be found in cell phones, PCs, network devices, e-commerce systems, and many more applications. C++ is another high-level programming language. It's also referred to as object-oriented programming language that builds on the C language. It contains everything that C does and adds the power of object orientation to it. Thank you.